Hello everyone, and welcome back to another video where we talk about grade 9 math. In this video we're continuing our discussion on data analysis and data representation. Today I will talk to you about two things. First, how to draw a box and whisker diagram and what is a box and whisker diagram, and the second thing is what outliers are. Alright. So a box and whisker diagram is a way to represent a data set that will always look something like this. Just a box with a line going through it somewhere. It doesn't have to be in the middle of it. It could be somewhere just inside the box with two lines coming out of the box, like horizontal lines, and then ending with two vertical lines. All right, so the reason we call it a box and whisker is because we have a box here, and then we have these two whiskers coming outside. All right, so it's a very simple naming for the literal shape of it. To draw a box and whisker diagram, we first need to have a data set, which I have right here. And then we just need 5 pieces of information to draw the diagram. That's all we need. The 5 pieces of information are the minimum value, the lower quartile, which I mentioned in the previous video. It's the data point at 25% of my data. We need the median, which is the middle data point at the 50% mark. Then the upper quartile, which is at the 75% mark. And then my maximum data point, which is at 100%. So if you think about it, it's at 0%, then 25%. Lower quartile is always also called Q1. So we call it Q1. The median, which is at 50%, we can sometimes call it Q2, but usually we just call it median. And then the upper quartile, which we call Q3, and it's at the 75% mark. And then the maximum, which is at the 100% mark. Okay, so let's look at the data set I have here, which is for just the numbers from 1 to 13. I kept it simple for now just to show you how to draw the diagram. Okay, so I just have the numbers from 1 to 13 in ascending order, so it's going to be easy to figure out where we are. The minimum is going to be my first point here. So that's 1. Okay. The maximum, I'm going to do it from the easiest thing to do to the hardest thing. The maximum is my last data point, which is 13. So that's my maximum. Now the median is usually the next easy thing to do for a data set like this. And it's the middle point in between my minimum and my maximum, which in this case, it's the number 7. Alright, now in between the number 1 and the number 7, the middle number between them is going to be the number 4. So that will be my Q1. That's my lower quartile. So that's 0% here, 25% here, 50% at the number 7. Okay, so it's 4. And then the upper quartile is going to be the number that is in between the median and the maximum, which is the number 10. And that would be the 75% mark. Okay, now that I have the information I need, what do I do? Well, we're going to start off simple. We're just doing vertical lines for each of these. So we'll start off from left to right. I'll do a line for the number 1. which is my minimum. And I'll just say minimum, and I'll write the number in between brackets. So minimum is 1. Then I'll do another line after it, moving right, for the lower quartile. So I'll say Q1, and in between brackets the value is 4. I'll skip again, draw another line for the median. I'll say M, and then 7, that's the value. Skip again. Upper quartile is 10. So I'll say Q3, in between brackets 10. And then my last line, max, and that would be 13. Okay, I drew just 5 vertical lines in order, and then starting from the minimum, just connect a line to Q1. Okay? And then at Q1, you don't connect a line through like that. No, you draw a box, so you connect from the top all the way to Q3. And you do the same thing from the bottom point. So I've made a box here that goes from Q1 to Q3, and then at Q3, just go through the middle to the maximum line. And that's it. As simple as that, I've drawn a box and whisker diagram. All right? Find more data sets in your question book, your textbook, and practice drawing a box and whisker diagram for these data sets. All right? Okay. The next thing I want to talk about is outliers. Now, outliers are part of data sets, so they are data points that are in my data set, but they can be data points that are very different from the rest of my data. What do I mean by that? Let's look at the picture I drew here. So imagine I got a data set for something I was interested about, like the heights of some tables in the house. Okay, I recorded this data, and then I plotted it on a graph. Okay, so here you go. I'm plotting the data on a graph, and let's say this is the height of the tables against the width of the tables. And I'm trying to figure some connection out. So some pattern in how the height versus the width of the table, is there a connection there or not? And let's say in my data, I saw this shape here. Well, I saw these points that way, and what we can see here is I kind of have a pattern, right? In a way, I kind of have this pattern that I can connect in kind of a straight line. Like they kind of make a straight line together. However, there's also these 2 points here that don't look like they follow the pattern I see in front of me. These are outliers. That's what we mean by outliers. Now, outliers can happen for a couple of reasons. They're not a good or a bad thing, by the way. And it doesn't mean I should eliminate them right away when I see them. It doesn't mean they're wrong. So outliers could happen because of errors. So they could be because of errors in recording the data, for example. Like I read something wrong. So human errors can happen. Okay? But it's not the only reason. So I can't always assume it's a human error. They can also be something called novel data. Okay, so novel is like new. So novel data. So it could be something, or it could also be something of an anomaly. So exceptional cases. They could also be exceptional cases. So still something that is measured correctly, but it is an exceptional odd situation that I can't, it doesn't follow the pattern that I see in front of me, but it does exist, it happens. So usually with outliers, further study needs to be made, but that's not something for you right now. It's something that happens and scientists do take it into consideration. But for you, just know what outliers mean. And that's it for today. For the next video, we're going to look more into outliers and how to spot them in a data set. There's a calculation we're going to learn how to do that helps us without looking at a graph. So we won't always have a graph in front of us. We'll just have a bunch of data points. So how to calculate where the outliers are when we just see a set of data. So I hope this video was useful. Thank you for staying along, and please do subscribe and share this video, like it, so that others can see it as well. Thank you, and I'll see you in the next one.